Welcome to this explainer. Today, we're diving into the absolutely wild and, frankly, terrifying science of what would happen if Earth's 4.5 billion-year spin just suddenly came to a halt. We're going to break down the catastrophic domino effect this would have on our atmosphere, our oceans, our gravity, and the very core of our world.
You know, what if the Earth suddenly stops spinning is a classic sci-fi thought experiment. But to truly grasp just how devastating that domino effect would be, we actually have to look at the hidden physical forces shaping our daily lives right now. Because we don't feel it day to day, it is incredibly easy to forget that we are just passengers on a massive, rotating sphere. Right this very second, if you're standing near the equator, you and everything around you are hurtling eastward at a staggering 1,670 kilometers per hour. That's roughly 1,100 miles per hour. You don't feel it because everything is moving right along with you. The ground, the oceans, the air, even your cup of coffee. It's kind of like being in a really smooth flying airplane. But what happens if the pilot instantly slams on the brakes?
Part 1. The supersonic atmosphere. Okay, so if the solid Earth instantly slammed on those brakes, the atmosphere absolutely would not. Thanks to the undeniable law of inertia, the air would just keep right on going at its original equatorial speed of 470 meters per second. To put that into perspective, the speed of sound is only 343 meters per second. This means the atmosphere would act like a supersonic global buzzsaw, literally scouring landmasses clean of anything that isn't firmly rooted to the bedrock. Every building, every tree, every unsecured object would instantly become a high-speed projectile. There's that great line from comedian Ron White about hurricanes, and it applies perfectly here. It's not that the wind is blowing, it's what the wind is blowing. The pure force of that supersonic wind is deadly enough, but the real danger lies in the high-speed debris pulverizing everything in its path. Now true, people at the exact north or south poles might be temporarily safe from the winds since they aren't moving relative to the Earth's axis, but for the vast majority of the planet, the surface would be instantly wiped clean. Moving on to part 2, the gravity shift. Let's just say you somehow survived those apocalyptic winds in a deep underground bunker. Well, once the chaos on the surface finally died down, you'd face a subtle but profound change in the very gravity you feel. To understand why, we have to look at centrifugal force. Currently, Earth's rotation creates an outward push that actually slightly counteracts gravity. It makes the Earth bulge at the equator, meaning its equatorial diameter is about 43 kilometers wider than its polar diameter. This centrifugal force effectively reduces your weight the closer you are to the equator. So, if we stop the spin, that centrifugal acceleration completely disappears. According to the formula for circular motion, a 70-kilogram person at the equator currently experiences a force that reduces their weight by about 2.4 newtons, or roughly half a pound. Without the spin, local gravity at the equator instantly increases by 0.034 meters per second squared. You would suddenly weigh about half a pound more just standing there. Which brings us to part 3. Migration of the oceans. Now, putting on a half a pound instantly might not seem like a massive deal to you and me, but this exact same loss of centrifugal force would drastically alter our oceans. Because water is a fluid, it responds instantly to these physical forces. Right now, there is an 8-kilometer high bulge of equatorial water held around the middle of the Earth purely by our spin. Without it, that water would immediately begin migrating toward the poles, where gravity is now strongest. Our current globally connected ocean would completely vanish. As all that water floods the northern plains of Canada, Europe, and Russia, along with Antarctica down south, a massive equatorial megacontinent would emerge. And interestingly, because of the unique relief of the ocean floor and our continents, the new hydrological divide, meaning the line separating the northern and southern polar oceans, wouldn't perfectly trace the equator. Its highest point would actually crest in the Colombian Andes at an incredible 12,280 meters, bypassing famous taller equatorial volcanoes like Chimborazo.
All right, part 4, a year-long day.
So, with this massive new geography settled, humanity would then have to face the brutal reality of a stationary orbit. Because Earth still orbits the sun once a year, a single solar day would now last an entire year. The sun-facing side of the planet would be subjected to 6 relentless months of baking daylight. Without the daily cooling of night, temperatures would soar, baking the surface and boiling away whatever water remained in that new equatorial desert. On the flip side, literally, the dark hemisphere would plunge into a 6-month sub-zero deep freeze. We're talking temperatures dropping far below any winter ever recorded. The oceans over there would freeze solid. The only potentially habitable region on the entire planet would be a narrow, perpetual twilight zone. just a permanent ring of dusk and dawn situated perfectly between the burning day and the frozen night.
And finally, part 5, death of the geodynamum.
Because the ultimate death blow to our planet wouldn't actually come from those surface conditions. It would come from deep within the core, erasing our planet's most vital invisible shield. Our magnetic field is generated by what physicists call the geodynamo. Deep inside the Earth, liquid iron convects in the outer core, driven by intense heat. But crucially, it's the Coriolis effect, caused by the Earth's rotation, that organizes this turbulent metal into a self-sustaining electrical current.
Let's trace exactly how this plays out. Without rotation, the Coriolis effect vanishes. The core convection loses its alignment, the geodynamo loop totally breaks down, and the magnetic field slowly dies. Without this magnetic shield, lethal solar winds would directly strike our atmosphere. Over millions of years, the sun would strip away our atmosphere and water, molecule by molecule, eventually turning Earth into a barren, irradiated wasteland, just like Mars. Now, before you go losing sleep over this, a sudden halt is physically impossible. However, the truly chilling part is that due to the tidal drag of the moon transferring angular momentum away from the Earth, our rotation actually is slowing down. We're losing about 1.5 to 2 milliseconds every single century. In fact, hundreds of millions of years ago, a day on Earth was only 22 hours long. While it would take billions of years for tidal friction to completely lock our spin to the sun or the moon, it does leave us with a haunting final thought. Our planet's rotation is the invisible engine that drives our winds, shapes our oceans, and shields our atmosphere. As that engine ever so slowly winds down, what will our dynamic blue marble ultimately become in the deep, distant future? Keep that in mind the next time you watch the sunset.